Okay, so in this part of the chapter, we're going to be taking a look at what are known as sublevels and orbitals. So in the previous session, we had looked at what are known as the principal energy levels, or sometimes these are just referred to as shells. Different textbooks use slightly different terms. And we saw that these energy levels, or these shells, these principal energy levels, are assigned with these numbers called principal quantum numbers that we designate with an n value. And n can be any integer starting with 1, 2, 3, 4, etc. As n increases, the energy of those energy levels increases as well. All right, so then we can say that n equals 3 has more energy than n equals 2. So it's a fairly straightforward relationship. The other thing that we can determine is how many electrons those energy levels can accommodate. And there's a formula that we can use. The maximum number of electrons that an energy level can accommodate is equal to 2n squared, where n is the energy level or the shell. So for example, for the third shell, or the third energy level, all right, that tells us that n is equal to 3. So if we substitute n equals 3 into our equation, all right, then we end up with 2 times 3 squared, which is 3 times 3. So that's 2 times 9, which is 18. So we have a maximum of 18 electrons that can be accommodated in that third energy level or shell. What we're going to do next is to take a look at each of these energy levels and see that they're actually sublevels or subshells that they contain. All right, so we're going to be looking here at sort of a hierarchy of how we gradually and slowly try to define where your electrons are going to be located. So sublevels are also called subshells. And your energy levels, your principal energy levels, are going to contain one or more of these sublevels or subshells. These are designated not by numbers, but by letters. They can be an S, P, D, or F, and these are all lowercase designations. Okay, so don't capitalize them. And these energy levels, the principal energy levels, n equals 1, n equals 2, etc., they contain a number of sublevels that is equal to whatever that n value is. All right, so for example, we'll start here at the bottom. For the first energy level, n equals 1, there's only one sublevel, and that sublevel is the S sublevel. So we designate that sublevel as the 1s sublevel. For the n equals 2, the second energy level, there are 2 sublevels. And whenever you have more than one sublevel, you always start with the S and you work your way across. All right, so this one here will be a 2s sublevel. And then we have another sublevel. We have 2 sublevels, so the S, and then we also have the P sublevel, and you'll see that there are 3 of these boxes, and we'll talk about those boxes in a little bit. So we call that a 2p sublevel. Right? We get to n equals 3. That tells us we're going to have 3 sublevels. So we start with the S, then we have a P sublevel, then we have a D sublevel, and then we'll designate those as the 3S, the 3p, and the 3d. And then we'll end with the fourth energy level. N equals 4 tells us we're going to have 4 sublevels, which will be the S, the P, the D, and now the F. And we'll designate these as the 4S, 4P, 4D, and 4F sublevels. All right, so the energy level that we're dealing with actually tells us how many of those sublevels we have, and we always start with the S first, and then we go S, P, D, F, depending on how many of the sublevels that we contain. So within those energy levels. We have these sublevels, either one or more of them if they're present. So if we have these different sublevels, S, P, D, and F, they actually don't have the same energy. They actually differ in energy in that order. So within a particular energy level, all right, the S is the lowest energy, the F is the highest, and then the P and the D are the next highest energy levels. So for example, we can say in the fourth energy level, all right, we can now say that the 4s is lower in energy than the 4p, which is lower in energy than the 4d, which is lower in energy than the 4f. All right, and again, this sign here, that means lower than or less than. So that's how the energies at the sublevels change as we go from one sublevel to the next. So we've talked about energy levels. Principal or main energy levels are shells. These contain one or more sublevels or subshells, which are the S, P, D, or F. And then these sublevels are going to contain now themselves one or more of things known as orbitals. Right, and this is where we're getting down into the nitty-gritty of where electrons are going to be located. So what exactly is an orbital? Well, an orbital is just a region in space that we define around the nucleus. So the nucleus is going to be at the center, where there's a high probability of finding the electron. All right, so for example, this diagram here on the right side kind of shows where there are high probabilities of finding your electron. So each of those dots would represent where an electron could be. So what we can do is we can draw a circle, or we can define that space, right? And we can say 95% of the time that electron is going to be enclosed within that circle, right? And we call that an orbital. At the very center of the orbital, or at the center of the atom, don't forget that we have that nucleus right there at the middle. Right, so all that orbital is just a region in space around the nucleus where there's a high probability of locating the electron. Electrons are very, very difficult to pinpoint. We can't really say with 100% certainty where they are located. Instead, we use probability, right? So there's a high probability of finding the electron in that space. So where are the orbitals located? Well, they're found within the sublevels. All right, so the sublevels contain the orbitals. So for example, the S sublevel contains one S orbital. And the S orbital has a very characteristic shape. It is spherical. Right, so all of these here are representations of S orbitals. We have the 1s orbital down here, the 2s, and then we have the 3s. You'll notice that they're all spherical. They all have that rounded shape. The only difference between them is their size. Right, so as a principal energy level, which is the number that we see there, as that increases from 1 to 2 to 3, the size of the orbital increases as well. But if it's an s orbital, it's going to have that spherical shape. The p orbitals are found in the p sublevels. Okay, so the p sublevel contains 3 of these p orbitals. So the p sublevel contains 3 p orbitals, and they They're going to have a very characteristic shape. The shape is described in a variety of ways, but it kind of looks like a figure of eight, or a bow tie, or hourglass shape. Right? They all three of them have that characteristic shape, and they're all aligned along the axes, the x, y, and the z axis. So we designate them, if p orbital lies along the x-axis, like this one here, we call it the 2p subscript x orbital. If we have another p orbital aligned along the y-axis, like this one, we call it the 2py. And if we have one aligned along the z-axis, we call it the 2pz. So all three of them are found in the p sublevel, and if you superimpose all three of them together, this is what you see here on the right side. All right, so those are the p orbitals that are found in the p sublevel, and we start encountering the p sublevels when we get to n equals 2 energy level and higher. So in the n equals 2 energy level, as we saw previously, we're going to have the 2s and we're going to have the 2p sublevels. The 2p sublevel, the 2s sublevel, like any s sublevel, is going to contain one s orbital, the 2s orbital. And the 2p sublevel is going to contain, like all p sublevels, will contain 3 of the 2p orbitals. All right, and we have them designated or shown down here. When we get to higher energy levels, n equals 3, we're going to see that this tells us, the 3 tells us we're going to have 3 sublevels. Okay, we're going to have the 3s, we're going to have the 3p, and we're going to have the 3d. The s sublevel contains just one orbital, the 3s orbital, like all s sublevels would. The p, the 3p sublevel, like all p sublevels, will contain 3 3p orbitals. And the 3d sublevel will contain 5 of the d orbitals, which are the 3d orbitals. All right, and those 5 d orbitals have an even more complicated shape. Okay, so they actually have several lobes as opposed to just 2 lobes in the as in the p orbitals. So there are 5 of these d orbitals. Right, each of these here represents a single d orbital. Right, they all look fairly similar, with the exception of this one that has a kind of a funky shape. When we get to the 4th energy level, okay, this is tells us we're going to have 4 sublevels. So we'll have the 4s, the 4p, the 4d, and now we're also going to have the 4f sublevel. So the 4s sublevel is going to contain 1 4s orbital. 4p sublevel will contain 3 4p orbitals. 4d sublevel will contain 5 4d orbitals. And the 4f sublevel now will contain 7 4f orbitals. And the shape of the f orbitals are even more complicated. We won't really touch on those. So these f orbitals have a much more complicated shape compared to all the other types of orbitals. Okay, so we've talked a lot about several different terms, and I I do understand that they can be a little confusing, so you may have to revisit the video a couple times, but definitely make sure that you read through the textbook as well. So let's recap a little bit where we just went to. We'll do a couple of these practice problems here. So it says indicate the type and number of orbitals in each of the following energy levels or sublevels, and we'll do C and we'll do D. All right, so n equals 3. This tells you that we're looking at the third energy level. Remember, the n value tells us the energy level. Okay, and the number just tells us how many sublevels we're going to have. We're going to have 3 sublevels. So we start with the S, so the 3s, then the 3p, and then the 3d. So the 3s sublevel, with all the s sublevels, we're going to have 1 orbital, the 3s orbital. The p sublevel, the 3p, is going to have 3 3p orbitals. And the 3d, like all the d sublevels, will have 5 3d orbitals. All right, for the second one here, we're asked specifically now about the d sublevel. Okay, so we're told that we're dealing with the 4d sublevel, and all the d sublevels, just like the 3d, for instance, will contain 5 4d orbitals. All right, so we've been using these terminologies and these ideas to eventually get deeper and deeper into the energy levels, then the sublevels, and then eventually into the orbitals. So how are the electrons going to fit into these orbitals? All right, well, we first of all have to know how many electrons can fit into an orbital in the first place. And to make a long story short, we can say, and we'll talk about the reason here in a second, each orbital, each single orbital can hold or accommodate a maximum of 2 electrons. That's a really important thing to keep in mind. And that is based on a principle known as the Pauli exclusion principle. And the idea behind that is quite simple, actually. Your electrons have a negative charge, and they're constantly spinning. And when they spin, they actually produce a magnetic field, right? So you're going to have a north pole, and we're going to have a south pole for an electron, right? Because it's a spinning negative charge. So in order for an orbital to hold those 2 electrons, the north and the south pole have to be paired up, right? So if this is one electron here with this north and south pole, the other electron has to be spinning in the opposite direction with the north and south pole flipped. To represent that, we use arrows to represent the spinning of the electrons. All right, so each arrow here in this box, so each arrow represents is an electron. Okay, and you'll notice that one is pointing up, one is pointing down. We see that this one here is spin up, and this one here is spin down. And that's how they pair up in an orbital. Okay, so they pair up with opposing or opposite spins in an orbital. Okay, so again, a maximum of 2 electrons in a single orbital. And we're going to use this idea in the next section to talk about orbital diagrams. All right, so our arrows represent electrons, and the box here, the box in blue, is an orbital. Okay, so that's why there's a maximum of 2 electrons in an orbital. It's based on the Pauli exclusion principle. So your S sublevel, if we kind of apply that to what we know now, all right, the S sublevel contains 1 s orbital. So if there's only 1 s orbital, it can hold a maximum of 2 electrons. The p sublevel, we said all p sublevels have 3 p orbitals, right? So 3 orbitals, each orbital can hold 2. So 3 times 2 would give a total of 6 electrons maximum. The d sublevel holds 5 d orbitals. So 5 times 2 per orbital would give a total of 10 electrons maximum. And then the f sublevel has 7 f orbitals. 7 times 2 electrons per orbital would give 14 electrons maximum. So we can use a fairly simple math to determine the maximum number of electrons that can be in each of these sublevels: the S sublevel, the P, the D, or the F sublevel. Okay, so now we can bring this all back to the very beginning of where we started the chapter and explain now why we had a maximum number of electrons that could be accommodated in an energy level, in one of these main principal energy levels or shells. So let's start here at the bottom. In our first energy level, n equals 1, we know that there's only 1 sublevel, which is the 1s. There's that s sublevel only contains 1 orbital, which is the 1s orbital. There's only 2 electrons that can be in there. So the first energy level then, n equals 1, can only accommodate 2 total electrons. For the second energy level, n equals 2, that tells us we're going to have 2 sublevels, which will be the 2s and the 2p. We know the 2s sublevel is going to contain 1 orbital, which is going to contain a maximum of 2 electrons. The 2p sublevel, like all the p sublevels, will have 3 orbitals. 3 times 2 would give a total of 6. So the second energy level then will have a total of 6 plus 2, which would be 8 total electrons. We can continue that further. We just do the third one. For n equals 3, that tells us we're going to have 3 sublevels: the 3s, the 3p, and the 3d. The 3s, as all the other s sublevels, can only have 1 orbital with 2 electrons. The p sublevel can have 3 p orbitals. 3 times 2 would give 6 electrons. And then the d sublevel can have 5 orbitals. 5 times 2 would give a total of 10. So in the third energy level now, we take all of these electrons, 10 plus 6 plus 2. That third energy level can accommodate a total of 18 electrons.